Scene script. Have you ever wondered why you can't jump as high as you'd like? The culprit is closer than you think. It's gravity. Gravity, that invisible power, the unseen force that keeps our feet firmly planted on the ground. It's the reason we can't jump to the moon or float down the street. But what is it exactly? Well, imagine a ball rolling down a hill. The force that pulls the ball downwards, that's gravity. It's a force that pulls us towards the center of the Earth, keeping us from drifting off into space. But here's where it gets interesting. Gravity isn't the same everywhere. It changes based on the size and mass of a planet. The larger and more massive a planet, the stronger its gravitational pull. That's why we feel so much heavier on Jupiter than on Earth, and why we could jump much higher on the moon than we can on our home planet. Think about it. If you've ever watched footage of the moon landings, you'll have seen astronauts bouncing around like they're on a giant trampoline. That's because the moon's gravity is only 1/6 of Earth's. With less gravity pulling them down, they could jump 6 times higher than they could on Earth. But what would happen if we went to a planet with even less gravity, or perhaps no gravity at all? Would we float away, lost in space forever? Or would we be able to jump so high, we could leap over mountains in a single bound? It's a fascinating thought, isn't it? And that's just the tip of the cosmic iceberg. There's so much more to explore when it comes to gravity, and its effect on our ability to jump. From the smallest asteroid to the largest gas giant, each celestial body has its own unique gravitational fingerprint, and each one presents a whole new world of jumping possibilities. So if you've ever dreamt of soaring through the air, you might want to consider a trip to a different planet. Imagine being able to leap over a house or jump across a football field. Sounds impossible, right? Not if you're on the right planet. This isn't a scene from a science fiction movie, but a reality when we consider the effects of gravity on our jumping abilities. Gravity, that invisible force, is what keeps our feet anchored to the ground. It's the reason why, when we jump, we don't just keep soaring into the sky. Gravity pulls everything towards the center of the Earth, and this pull is what limits how high and far we can jump. Here on Earth, gravity is a constant, a force we can't escape. It's the reason why even the most elite athletes can only jump a few feet in the air. But what if we could change that constant? What if we could alter the pull of gravity? That's where our journey to other planets comes in. You see, gravity isn't the same everywhere. It varies depending on the mass of the planet. So on a planet with less mass than Earth, the pull of gravity would be weaker. And with weaker gravity, we could jump higher and further than we ever could on Earth. Take the moon, for instance. It's only got about 1/6 of Earth's gravity. That means if you could jump 3 feet high on Earth, on the moon, you could jump about 18 feet high. Imagine the basketball games we could play there. Or consider Mars. It has just over 1/3 of Earth's gravity, so your 3-foot jump on Earth would become a nearly 9-foot jump on Mars. You'd be able to jump over a car with ease. But let's not stop there. On a tiny moon like Deimos, one of Mars's moons, you could jump so high and so far, you might even be able to jump into orbit. In the realm of the cosmos, your Olympic high jump dreams could become a reality. Ready to take a giant leap? Let's investigate how high you could jump on different planets. Our journey through the cosmos begins on Mercury, the smallest planet in the solar system. Its gravity is just 38% of Earth's. This means if you can leap 1 meter high on Earth, you could make a jump of over 2.5 meters on Mercury. Next stop, Venus. Despite being similar in size and mass to Earth, Venus has a slightly lower gravity, 89% of Earth's to be precise. So your 1 meter jump on Earth translates to approximately 1.1 meters on Venus. On to the red planet Mars, which has only 38% of Earth's gravity. Your earthly 1 meter jump would become an impressive 2.5 meters on Mars. Now let's leap to the gas giants. Jupiter, the largest planet in our solar system, has a gravity 2.5 times stronger than Earth's. So your 1 meter jump shrinks to a mere 40 centimeters. Saturn, the ringed beauty, has gravity that's just over 1 times that of Earth. Your jump here would be around 90 centimeters. The ice giants, Uranus and Neptune, offer similar jumping heights to Saturn thanks to their similar gravities. Finally, we venture to the dwarf planet Pluto, where the gravity is a minuscule 6% of Earth's. Your 1 meter jump on Earth would catapult you to an astounding 16 meters on Pluto. Imagine the view from up there. In summary, the height of your jump varies greatly depending on your location in the solar system, all thanks to the invisible force of gravity. From the rocky surfaces of Mercury and Mars, to the gas and ice giants and even the distant dwarf planet Pluto, each presents a unique jumping experience. So next time you wish you could jump a little higher, remember it's not you, it's gravity, And who knows, maybe one day you'll get to test out your jumping skills on Mars or even Jupiter.